Why did Python strings change from ASCII to UTF-8? Have you ever wondered why Python strings shifted from ASCII to UTF-8? This change was essential for programming in today's diverse digital world. Let's break it down step by step. First, let's talk about ASCII, which stands for American Standard Code for Information Interchange. ASCII uses 7 bits to representing characters, allowing for only 128 unique symbols. This set mainly includes English letters, numbers, and some basic punctuation. While it worked well for early computers focused on English, it fell short for languages around the globe. As the need for a wider range of characters grew, Unicode was introduced. Unicode assigns a unique code point to every character used in human languages. This system covers tens of thousands of characters, including accented letters, symbols from languages like Chinese and Arabic, and even emojis. Now, here comes UTF-8, which stands for Unicode Transformation Format, 8 bits. UTF-8 encodes Unicode code points into bytes. It uses a flexible length encoding scheme that remains compatible with ASCII for the first 128 characters. This means that any ASCII text is also valid UTF-8. UTF-8 can efficiently encode all Unicode characters, using 1 to 4 bytes per character. Before Python version 3, strings were mostly limited to ASCII or bytes. This restriction made it challenging to handle international text. With the releases of Python version 3, the core string type was updated to store Unicode characters directly. The default encoding for source code was set to UTF-8. This change allows programmers to write Unicode characters directly in string literal. Internally, Python strings are sequences of Unicode code points. When these strings are stored or transmitted, UTF-8 encoding is commonly used. This transition brings several practical benefits for Python programming. For one, it allows developers to write programs that handle text in any language without running into encoding errors. It simplifies working with web data, files, and network protocols that typically use UTF-8. This change also helps avoid common bugs related to character encoding mismatches. Errors like Unicode encode error or Unicode decode error become less frequent. Additionally, using UTF-8 allows for the inclusion of emojis and special symbols in strings, which are increasingly popular in modern communication. In Python, strings are Unicode objects. If you want to convert a string to UTF-8 bytes, you can use the encode method with UTF-8 as the argument. To convert UTF-8 bytes back to a string, you would use the decode method with UTF-8. This clear distinction between text and data helps prevent encoding-related bugs. In summary, Python moved from ASCII to UTF-8 to embrace Unicode fully. This change allows for universal text representation and addresses the limitations of ASCII. It aligns with Python's goal of making programming easier and more effective when dealing with text data worldwide.